Hello everyone, my name is Ahmet Uğur Özen, and today I'm going to give brief information about the effects of porosity defects on carbon fiber reinforced polymer composite parts. Due to the high stiffness to weight ratio of the carbon fiber reinforced polymer composite parts become more popular in industrial applications. Carbon fiber reinforced polymer composites rely on carbon fiber to provide strength and stiffness, while the polymer provides an adhesive matrix to protect and hold the fibers together. Carbon fiber reinforced polymer composites shows highly directional stiffness than the metals, and these carbon fiber reinforced polymers are widely used in the industry. However, their challenging manufacturing procedures can result in many defects that adversely affect the mechanical and shape properties. Porosity defect is one of the most common composite defects, and it directly affects the mechanical properties of carbon fiber reinforced polymer composite parts. Formation of the porosity defects rely on the manufacturing techniques. There are three main manufacturing techniques, which are resin transfer molding, automated fiber placement, and prepreg lamination. The resin transfer molding process is one of the most popular methods for producing carbon fiber reinforced polymers due to its versatility and low cost. In this process, polymetric thermoset resin injected into the mold cavity, which is preloaded by a multi-layer fiber reinforced preform. This figure illustrates the resin transfer molding process schematic. During this resin injecting process, by using a hydraulic press, the air pushes out from the mold and fibers get wet. Hydraulic press pressure, resin viscosity, and temperature are the process parameters for this production technique. Due to insufficient resin viscosity, low pressure or low temperature can cause unremovable air and dry areas, which can create a porosity. Automated fiber placement process, which known as also AFP process, is the manufacturing technology that is increasingly used by industry. This process consists of cutting, curing, and consolidation in one placement head. Because of the complexity of this process, the consolidation force, layup speeds, and temperature should be optimized for error-free production. This figure shows the schematic of the automated fiber placement technique. There are some research shows that the low consolidation force or low temperature can cause a porosity content in the specimen. These figures shows that the porosity volume of the different specimens under different consolidation forces and hot gas torch temperatures. As you may see in these figures, porosity volume will decrease with increasing consolidation force. And also, again, the porosity volume can decrease by hot gas torch temperature increases. The final production technique is prepreg lamination, which is also known as the autoclave curing process, which is an important method for the manufacturing composite parts. In this process, pre-impregnated sheets are stored into the cold to prevent curing. Then these plies are cured into the mold under high temperature and pressure to obtain stiff structural parts from prepreg layup. Dwell time of the polymer matrix and autoclave pressures are two important process parameters of this production method. Various studies shows that autoclave pressure has a direct effect on the void content on the CFRP composites. As you may see in this figure, void content is decreased by increasing cure pressure. Inspection method is also important to understand the porosity content on the specimen. These inspection methods are highly used in the industry to identify these defects. There are lots of inspection methods, but I'm focused on the double true transmission ultrasonic test and the computed tomography test, which too is the most common non-destructive inspection methods to identify porosity. But some papers shows that scientists also need to destructive tests to better characterize the pore size, shape, and location through the laminates. Mechanical effects of the porosity defects is one of the main topics of that project. The porosity defects affect the carbon fiber reinforced polymers composite parts' mechanical properties. There are many studies to show these phenomena in the light of the fatigue, strength, and stiffness tests. As you may see in the figure, flexural modulus is reduced dramatically than the tensile modulus. The main reason is that voids, which also known as the porosities, occurs at the matrix between laminates, and these voids can create a cracks and delamination under flexural loading, and these delaminations and cracks leads to reduced flexural modulus of the composites. The in-plane shear properties of carbon fiber reinforced polymers composite parts are also reduced with increasing void content. Several studies shows that the maximum shear stress and shear modulus is reduced when the number of porosity increases in the specimen during the V-notch shear test. These two figures illustrate this phenomena directly. Scientists also investigate that the fatigue life of the carbon fiber reinforced plastic composite parts is very sensitive to porosity concentration. During fatigue test, not only crack density, but also the number of delaminations are increased with increasing void content. As a conclusion, due to high stiffness weight ratio of the carbon fiber reinforced polymer composite parts become more popular in industrial applications. Voids are one of the most critical manufacturing defects because of their effects on the mechanical properties of the material. These porosities can be observed at each manufacturing process due to errors in process parameters, low pressure, low temperature, or insufficient resin viscosity, which can creating voids in carbon fiber reinforced plastic composite parts. The automated fiber placement process become more popular, but low concentration force or low temperature can cause a void in the production. Also, the dwell time of the polymer matrix and cure pressures are very critical process parameter for proper lamination process. Voids are created by process parameter errors. To understand the distribution and size of these porosities, we need some inspection methods. Thanks to these methods, the effects of the porosity defect studies are improved year by year. The result of these studies shows that the porosity affects the mechanical properties of the carbon fiber reinforced polymer composite parts significantly. Flexural modulus, tensile modulus, shear strength are reduced with increasing pore content. Also, crack density is increased with increasing void content during the fatigue test. For the future work, understanding the effects of the defects in composite structures is becoming more important in the use of the fiber reinforced composites and how they affect the durability and safety of engineering structures such as aircraft, ships, bridges, and wind turbines. The mechanical test showed that porosity defects on carbon fiber reinforced plastic composite parts reduced mechanical properties of the material. But to understand this, scientists did so many tests and they spent so much time. It's hard to apply this test for every composite production method. Instead of spending so much time on this testing, future scientists should work on developing finite element methods to understand how these composites defects affect mechanical properties. In this way, scientists can spend much less time and observe how these errors affect the mechanical properties of composite materials for newly developed production methods. These are my references. Thank you for your listening.